Let's talk about the VisionJet electrical system in a way that you might not be used to. Welcome to another real-world SF50 flying video. This one is titled Circuit by Circuit, a different way to look at the SF50 electrical system. Hello, I'm David Weeks. I've been flying professionally for over 50 years, starting as a CFI, then a charter pilot in Light Twins. I spent time as an air ambulance pilot in a Swearingen Metro, and I worked as a demonstration pilot for the Learjet factory. I had a 35-year airline career flying the Boeing 737-200 and 300, the A320 series, and I retired as a Boeing 787 captain. I'm also a current CFII. I've got over 700 hours in the SF50, and I'd like to share my SF50 experiences with you. Now, there may be other YouTube channels that have glitzier production values than this one. I like to spend my time writing and teaching about the SF50, not doing post-production work, so just imagine this video as like a hangar chat session between friends. First, I do want to state clearly that the procedures in the Cirrus VisionJet airplane flight manual and the information in the pilot's information manual are always controlling. This video is not flight instruction, nor is it ground school. These are simply my thoughts about the various circuit breakers in the VisionJet. Traditionally, aspiring VisionJet pilots are taught the electrical system by learning the schematic in the pilot's information manual electrical section. We learn the generator max amperage output and voltage, and the battery amp hour rating and voltage, what a crossover diode is and does. We learn what powers the main, essential, and emergency buses and the normal and failure modes. And we study the various checklists for generator and battery failures. Now, all this learning is needed to understand the SF50 electrical system. However, in my experience, entire buses rarely or never fail by themselves. A total bus failure, meaning a short circuit in the bus wiring itself, for example, means the loss of every component wired to the bus. Now, more realistically, a bus may lose its power source, but then a backup power source takes over. Learning the electrical system from this perspective, while very important, doesn't really help you understand what happens to each system when its circuit breaker pops. As we know, circuit breakers usually open in the event of a short circuit in a given component, or else to prevent excessive amp draw due to malfunction. The malfunctioning system is isolated, we run any applicable checklist, and hopefully life and the flight go on. But I doubt that many pilots have thought about every circuit breaker that's on the airplane and considered what happens when that breaker pops. What is actually lost and how important is it? This is the first of several videos in which I'll discuss each circuit breaker in the SF50 and what happens when it opens. I'll begin with the cockpit-located circuit breakers going row by row. After that, I'll touch on the various breakers in the nose and baggage electrical panels. I'm going to keep these shorter than usual as there's a lot to digest in each one. The circuit breaker diagram for the pilot side I'm going to use is the one on Pilot's Information Manual, page 11-10. The PIM revision is number 7. And the circuit breaker diagram for the co-pilot side I'm going to use is the one on PIM page 11-11. And the revision number is number 7. This applies to serial numbers 5 through 454. Now, I'll have PDFs of these two circuit breaker panels in the comments section, but in any event, it'll be much easier to follow along if you have a graphic of each circuit breaker panel. Ready? Let's jump right in. Breaker A1 is pitch trim. It is on the essential bus. If you lose it, you lose the ability to electrically trim the pitch axis. You do not lose the ability to manually trim. Now, the discussion of safe return on AFM page 30 says that safe return performance will be degraded if the AFCS or pitch trim servos are lost. And yeah, I'll bet that's true. This circuit breaker is referenced in the pitch trim runaway checklist, and it's also mentioned as a component that is lost when the essential bus is not powered, as discussed on AFM page 3-41, the emergency bus volts checklist. It's also going to be used if you have a pitch MET or manual electric trim active CAS message. This message comes up if the manual electric pitch trim is in use when not commanded by the trim switch on the control stick. Now, do not confuse the pitch trim servo with the autopilot pitch servo. They are two different motors. Now, one little tidbit that I learned when researching this video comes from the Garmin G3000 Perspective Touch Plus manual. Page 55 says, quote, "The pilot side trim switch has priority over the co-pilot side trim switch." And I did not know that before. Circuit breaker A2 is the roll trim circuit breaker. It too is on the essential bus. This is the electrical motor used to adjust the trim tab on the left wing. As you know, there is no manual roll trim. Now, I cannot find any reference in the Garmin manual to a roll met active cast message. So you won't get a cast message if you get a roll trim runaway. The roll trim runaway checklist is not a boxed or memory checklist. If you wait to pull the A2 roll trim circuit breaker until you get the checklist up on the screen, you're probably ending up with the roll trim all the way over. Now, the checklist says, quote, "Airspeed reduce as required to minimize force." Now, you'll have to deal with that all the way to the ground as you cannot manually trim the roll axis. If the trim runaway resulted in full left roll trim being applied, and you need to hold half right stick deflection, for example, to maintain wings level, you're fairly restricted in the ability to bank more to the right. So take this into account if you have to make a crosswind landing with the wind from the right and you add left rudder in the flare. You won't have all that much extra right aileron remaining to get the right wing down. Circuit breaker A3, the autopilot servos. This means the autopilot pitch servo and roll servo. And this has nothing to do with the yaw damper or the yaw SAS system. Pulling this breaker, or if it pops, means that you have no autopilot. You also lose the stick pusher, enhanced stability protection, and underspeed protection. Now, A3 is referenced in the memory item emergency checklist for automatic flight control system malfunction: stick pusher, ESP, USP, and autopilot. Now, losing this system affects only the autopilot pitch and roll servos. You do not lose the flight director. And the yaw damper system has its own servo and circuit breaker. Oh, and don't forget, if the autopilot fails its pre-flight test, you are grounded. If you have authorization to use the SF50 Master MEL, be aware that the autopilot is not listed in the MEL, so it must be functional. And if you don't have MEL authorization, then you should already know that for turbojets, FAR 91.213 requires every component to be operational. You cannot dispatch the SF50 with an in-op autopilot. Now, if the autopilot fails in flight, you can keep going, but you cannot enter RVSM airspace, and RVS airspace is the airspace above flight level 280. If your autopilot fails while in RVSM, you got to notify ATC. You can ask to stay in RVSM airspace, but ATC doesn't have to let you stay there. Circuit breaker A4 is the throttle servo. This is on the essential bus. It's the motor that moves the throttle when the auto throttle is engaged. It's also used by the safe return system. It's simple. This breaker pops, and you have to move the throttle by hand. Safe return won't work properly. You may get a throttle servo caution cast message if the system fails. Don't forget that CAPS activation will require manually retarding of the thrust lever to idle. If you're authorized to use the SF50 Master MEL, you'll find that you can dispatch with the auto throttle on MEL. It lists the numerous systems that will be inoperative and those that depend if the airplane is equipped for emergency auto land or not. Emergency descent mode and CAPS are effective. Circuit breaker A5, the yaw damper. Now, the pilot's information manual says that the yaw damper is optional, but I've never heard of an SF50 without one. It's on automatically from 200 feet AGL on the climb until 200 AGL on landing. The Master MEL does allow dispatching without the yaw damper system as long as the circuit breaker is pulled and collared. And no, I have no idea how the airplane flies without the yaw damper. Breaker A6 is engine IPS or ice protection system 1. There is also engine IPS 2 located at position D9 on the co-pilot circuit breaker panel. Both are on the essential bus. This means there are two separate circuits to control the engine IPS system. If one fails, the other should be able to control the circuit. We know the engine inlet is heated by bleed air, but the PT2 and TT2 probes are electrically heated. Now, I cannot find any specific documentation for this statement in the PIM, but I suspect that the engine inlet heat burst-off valve, or pressure regulating and shutoff valve, is powered closed and it fails open when electrical power is removed. This means you wouldn't lose engine inlet heat if there's an electrical failure resulting in a loss of power to both IPS 1 and 2. Now, this kind of design is common in many other jet airplanes, but again, I can't confirm this to be the case. Consider the IPS engine inlet on CAS message in accompanying checklist. This CAS message occurs when the engine IPS should be off, usually due to warm outside air temperature, or because the solenoid has failed to close the bleed air flow into the inlet. The checklist specifically mentions that if recycling the engine IPS switch does not cause the CAS message to clear, and to remove power from the engine IPS system, you have to make sure that both engine IPS 1 and 2 circuit breakers are set, meaning closed. You're trying to close the solenoid, so both circuits have to be powered. This means the system fails to the on position. And I think the same logic applies to a TT2 heat fail CAS caution message. Circuit breaker A7 is APCTRL, meaning autopilot control. It's powered by the emergency bus. The autopilot controller is the GMC 707 panel that we use to command the various autopilot modes. No power to this panel means no autopilot nor the flight director. Now, don't forget that you can have various autopilot problems like servo failures and still be able to program the flight director from the autopilot panel. But if this panel is not working, you won't even be able to use the blue level button. Now, there is only one mention of this circuit breaker in both the PIM and AFM. Circuit breaker A8, probe heat left. It too is powered by the emergency bus. This powers the heater for the left wing pitot tube. The right probe heat, circuit breaker at position E4, powered by the essential bus, controls the right wing pitot tube heat and also the electrical heating for the angle of attack main. Now, for obvious reasons, the OAT, or outside air temperature probe, is not heated. Circuit breaker A9 is fire protection 1. This is another emergency bus circuit. The PIM says that fire bottle 1 and the fire detection system are powered through this circuit breaker. While the PIM is not specific, I suspect that this means the squib for fire bottle 1 is what's being referred to. Now, the fire detection system it's the helium loops that detect excessive temperatures in the engine compartment. So if this circuit breaker pops, you won't even know that a fire may be underway, and you won't be able to discharge fire bottle 1. But since this is an emergency bus circuit, the chances of that hopefully are very, very small. Now, since we're talking about this important system, circuit breaker B9 covers fire protection 2, also on the emergency bus. This is power to the squib for fire bottle 2 and also the fuel shutoff valve. No power to this circuit means you can't close the fuel shutoff valve, nor can you activate the squib on fire bottle 2. So, what can we learn from this? What I learned is that I don't want to have an engine fire without any power to either circuit breaker A9 or D9, but I don't really lose any sleep over it. Circuit breaker A10 is cabin pressure 2, yet another emergency bus circuit. While there's also a cabin pressure 1 circuit breaker, the two breakers protect different systems. The PIM says this about cabin pressure 2, quote, 28 volt DC for the outflow manual dump operation is supplied through the 2 amp cabin press 2 breaker on emergency forward panel 1. This is the power to open the outflow valves in a manual cabin pressure dump when the cabin dump guarded push button has been pressed. Now, to me, this sounds as though the cabin dump push button is wired directly to the 2 outflow valves located on the aft pressure bulkhead and will open them even if the cabin pressure controller system has failed. So let's talk about the cabin pressure 1 circuit breaker, which is located at D8 on the right side of the cockpit. This circuit is for the cabin pressure controller system. Lose this and you lose the CPCS. Now, one good thing to note is if the cabin pressure controller fails, the CPCS will maintain current cabin altitude. The outfall valves won't just go full open or full close, and to me, that's a reassuring thought. If you lose the controller in cruise, say at flight level 310 with a cabin altitude of 8,000 feet, the system should hold the 8,000 foot cabin altitude until the aircraft descends below 8,000 MSL, and then the cabin will descend at the airplane rated descent. Now, I'm not going to get into what happens if you're landing at a high altitude airport and the CPCS has been operating in high field elevation mode before it failed. But suffice to say, you do not want to land with the cabin pressurized. Now remember, the before landing checklist has you check the cabin differential pressure to make sure it's approaching zero. And if you need to turn the bleed switch to fresh to let the cabin depressurize, just make sure you do so well before touchdown. Now, the master MEL does, in fact, allow you to dispatch with the cabin pressurization system inoperative. As you might expect, you have to pull and collar some circuit breakers and also select on for the cabin pressure dump switch and comply with various Part 91 oxygen regulations. If you elect to do this, be sure that you have read and understand the MEL and know that you'll have one and possibly two CAS messages staring you in the face all the time. Circuit breaker A11 is crew lights. These are the two circular white lights located on the overhead. They are the only lights, I'm sad to say, that are powered by the emergency bus. Yep, you heard correctly. All you have are these two little white lights. To be sure, the PFD and the standby attitude and airspeed MD320 are internally illuminated. But bring a good flashlight along. In fact, bring two. While we're on lighting, the crew micro spotlights are powered by the instrument dimmer circuit lights Inster lights breaker at position E1. They're on the essential bus. The convenience light operation is supplied through the conv lights circuit breaker on the battery 1 hot bus. Now, where is this breaker located? It's not on either panel in the cockpit. You'll find it on the aft circuit breaker panel that's located on the forward wall of the aft external baggage compartment. So there's no access in flight to this circuit breaker or any of the several more important circuit breakers on this panel. We'll talk more about this panel and the nose circuit breaker panel later on. Now let's look at the breakers on row B. B1 is oxygen packs. As you no doubt recall from ground school, the oxygen flow to the drop-down passenger mass is controlled by the passenger oxygen solenoid control valve. The solenoid can be powered automatically by 2 high cabin altitude or manually by turning the PAX oxy deploy switch from auto to on. This circuit breaker is on the essential bus. And by the way, just what the heck is a solenoid? Now, a solenoid is an electromagnetic device that converts electrical energy into mechanical motion. So you put power to the solenoid and it will open the passenger oxygen valve. Now the breaker at B2 is bleed air flow control. It's on the main bus. This is not the valve that controls bleed airflow out of the engine. This is the mass flow control valve, and the mass flow control valve has two positions, high flow and low flow, that regulates the airflow to the cabin. Now the PIM is not specific as to what position the valves fail in if there's a loss of power. However, in normal operations, the valve is in the low position unless you select defog or the cabin needs rapid heating. B3 is the stick shaker circuit breaker. It is on the main bus. This is the circuit breaker protecting the circuit that powers the motor that moves the eccentric weight to make the control stick shake. Now, this has nothing to do with the stick pusher. The pusher is driven by the pitch servo. B4, landing gear hydraulic, another main bus system. This is for the hydraulic pump that operates the landing gear. If you need to manually extend the landing gear, the checklist has you pull this circuit breaker. Don't forget, if you manually extend the landing gear, you will not be able to retract it unless you reset the circuit breaker. Guys often forget this subtle point in the sim, and I am one of them. Another thing to consider is that with the generator 1 failure, generator 2 is not able to power the main bus. Only bat 1 can then power it. Now, if you turn off bat 1 to conserve its power in the event of a generator 1 failure, just turn it back on when you need to lower the landing gear for landing. Just because you've lost Gen 1 does not necessarily mean that you have to manually extend the gear. Now, in the interest of both brevity and clarity, I'm going to talk about several circuit breakers now that have several things in common. B5, B6, B8, C4, C8, and C9. These breakers protect the power to the screens, the GIAs, and GTCs in redundant ways. In the SF50, the systems that are very important to the safe operation of the aircraft. The PFD and the MFD are physically identical, but they obviously have different functions. And the same is true of GTC 1, 2, and 3. The GIAs, officially known as Garmin Integrated Avionics Units, are also very important. Now, my SF50 initial ground school did not say all that much about what the GIA or Garmin Integrated Avionics Unit really is. You need to go to the Garmin G3000 Perspective Touch Plus manual to learn more. Now, here's a juicy tidbit of info from the G3000 manual. Quote, the Integrated Avionics Unit, IAU, function as the main communications hub linking several LRUs, or line replaceable units, with each on-side GDU, or Garmin display unit, which we know as the PFD or MFD screen. Each IAU contains a GPS satellite-based augmentation system, or SBAS receiver, a very high frequency or VHF communication, navigation, and glide slope COM-NAV-GS receiver, a flight director, and systems integration microprocessors. That tells me that I really don't want to lose the GAA, as it controls a whole lot of important systems. But fortunately, we have two GIAs in the Vision Jet. And when we look closely at what these circuit breakers protect, we see that Cirrus has designed the system to provide multiple sources of power for these very important systems. We'll also see that the labeling on the circuit breaker panel itself is not always the same as the labeling in the PIM, and this may be confusing to some people in some cases. B5 is the breaker for GTC2A. GTC2 may perhaps be the most important of the three GTCs, or Garmin touch controllers. While it's true that GTC1 doubles as a standby attitude and airspeed instrument, GCT2 handles pain management and a lot of other important functions during abnormal operations. Because of its importance, Cirrus provides two ways of powering GTC2. The PIM tells us that GTC2A is powered by the emergency bus and is actually named GTC2 main. GC2B is at location C9 and is on the main bus. The PIM names this MFD secondary, GTC2 secondary. B6 is labeled GPS nav GIA1. There's a whole lot of stuff going on with this breaker. The PIM labels it GIA1 main nav GPS and GIA1. Breaker B4, MFDA, and GTC3. This is an essential bus circuit. The other circuit for the MFD is just a bit further down the C row at C9, which is MFDB and GTC2B. That is a main bus system. Now, either one can power the MFD. B8 is labeled PFDA, but the PIM names it PFD main, and it's on the emergency bus naturally. This breaker is not a dual circuit breaker. All it handles is the PFD. C8 is PFD-B and GTC1B. This is a main bus breaker. Again, note how the pilot's information manual labels this PFD secondary and GTC1 secondary. Circuit breaker C9 is MFD-B and GTC2B, again, a main bus system. The PIM calls this MFD secondary and GTC2 secondary. These are important systems with redundant sources of electricity. And I'll quote from the PIM. 28-volt DC for integrated avionics unit 1 operation is supplied through the 2-amp GPS nav GIA1 and the 5-amp COM1 circuit breakers on emergency panel 2. 28-volt DC for integrated avionics unit 2 operation is supplied through the 2-amp GPS nav GIA2 and the 5-amp COM2 circuit breakers on essential panel 2. Now, my takeaway for this design, and it's only my opinion, is that this allows for more redundancy for the screens, GIAs, and GTCs while having fewer circuit breakers overall. Main and secondary power for each one is distributed among 2 circuit breakers, and that means the failure of, for example, a malfunction that causes breaker C8 to pop and lose power to PFD secondary and GTC1 secondary will not affect the main power for those 2 systems. Sure, Cirrus could have completely separate breakers for the primary and secondary power for each screen, GIA and GTC, but that would significantly increase the complexity of the wiring. Let's move now to circuit breaker B9. This is fire protection 2. We discussed this earlier when we talked about the fire protection 1 circuit breaker located at A9. B10 is AHRS or AHRS1, the Attitude Heading Reference System. It's powered by the emergency bus, as one would expect. The AHRS2 circuit breaker is located at F5 on the right side circuit breaker panel. Number 2 is a main bus system. This circuit breaker also protects air data computer 2. B11 is ADC1, the number 1 air data computer. This, as you might guess, is another emergency bus system. Its counterpart, air data computer 2, a main bus system, has its circuit breaker at F5, and that breaker also handles ARS2. Now that we finally covered rows A and B, let's move on to row C. C1 is ECS CTRL, ECS control. ECS stands for Environmental Control System. This is an essential bus system, and here's what the Pilot's Information Manual has to say about ECS Control 2. Pulling this circuit breaker removes power to the ECS control panel and TCV, or temperature control valve, causing TCV to spring open. Now, what does this really mean? Be aware that with the temperature control valve full open, this maximizes the ram airflow or ground fan airflow through the bleed air system heat exchanger, and that will result in a cold cabin temperature. Now, since we're on the environmental control system, you'll find ECS control 1 at position E1 on the right side of the cockpit. Pulling this circuit breaker removes power to the ECS ECU. Now, the PIM does have a bit more to say. ECS control 1. Pulling this circuit breaker removes power to the ECS ECU. Okay, but note, temp backup mode is still selective when ECS control 1 is pulled. Now, if you can't remember what the ECS ECU is or does, here's one thing it does. This is from the PIM. Quote, the ECS ECU automatically controls the flow setting, high or low, of the flow control valve based on cabin heating and cooling needs. Quote. Another function of the ECS ECU is to talk to the primary and secondary temperature anticipator sensors for better cabin temperature control. Now, while I can't say for certain, given the lack of detail in the information manual, it certainly sounds like losing either ECS control 1 or 2 is going to make it harder to control the cabin temperature. Circuit breaker C2 is flaps, and finally, we get another easy one to discuss. This is for the flap electric motor, and it's an essential bus circuit. The PIM labels it as flap actuator. Okay, no flap motor or actuator, no flap movement either up or down. Now, if you're unlucky enough to have the flap circuit breaker pop right after takeoff, remember to not exceed the 199 indicated maximum speed for flaps 50%, and you'll be landing flaps 50% too. But let's say the flap breaker pops when extending the flaps in flight, and the flaps are between up and 50%. There is a checklist for flaps inoperative, but the AFM does not really define what inoperative means. It does tell you to fly to the green donut for approach speed. Circuit breaker C3 is generator 2. You'll recall this is the 76 amp, 28.7 volt generator that normally powers the essential and emergency buses. Gen 2 is really an alternator whose alternating current output is finagled to become direct current. So maybe, just maybe, that's why the PIM labels this as the alternator control unit. If you lose Gen 2, we know that Gen 1 can power the entire electrical system. And by the way, the only checklist that has you touch the generator 2 circuit breaker is the generator 2 current checklist. Okay, now let's talk about the generator 1 circuit breaker, which is at wait, trick. There is no Gen 1 circuit breaker. Why not? That's because Gen 1 is controlled by the generator control unit, or GCU. If generator 1 malfunctions in flight, the generator may be reset by momentarily touching the GCU Gen 1 reset button on the aircraft systems page on GTC2. How do you find it? Using GTC2 from home, touch aircraft systems, then touch the GCU reset button. And as a reminder, if you lose and cannot reset Gen 1, then BAT1 will power the main bus until such time that you might turn it off to save it for closer to landing, allowing you to extend the landing gear normally. And lastly, if Gen 1 fails, some load shedding will automatically take place. If Gen 1 fails, the air conditioning loads will be automatically disabled. It would not be good to force BAT1 to assume the high amp draw air conditioning and fan electrical load. This would quickly deplete BAT1 if you failed to turn it off right away. So Cirrus load sheds the air conditioner and fan automatically. C5, another easy one, nav lights. This is another system that's listed in the Master MEL. It refers to them as position lights. The Master MEL allows the nav, or position lights, to be inoperative between sunrise and sunset. C6 is GPS nav and GIA2, an essential bus breaker. We talked about the GIA and GPS power when we discussed breaker B6 earlier. C7 is COM2 and the audio panel, another essential bus system. Aside from powering the audio panel itself, this is where the 28 volt DC for the headset and microphone system comes from. So we have COM1 on emergency and COM2 and the audio panel on essential. C8 is PFD-B and GTC1B. This is a main bus breaker. Again, note how the PIM labels this PFD secondary and GTC1 secondary. C9 is MFD-B and GTC2B, again, main bus systems, and the PIM calls this MFD secondary and GTC2 secondary. Circuit breaker C10 is fuel pump CTRL, or fuel pump control. This is a bit deceiving. The PIM names this fuel control panel. This is the right-left tank switching, not the fuel pump that pumps fuel in the fuel system. This is on the main bus. Now I'm going to skip a bit out of sequence and tell you that the circuit breaker for the fuel pump itself is located on the aft circuit breaker panel and is labeled fuel pump power and is on the essential bus. The PIM names it electric fuel pump. Last but not least on row C is C11, igniter 1. It's on the main bus, and jumping ahead, igniter 2 is at D9 on the copilot circuit breaker panel. This is an essential bus circuit. What can we conclude from the fact that igniter 1 is on the main bus and igniter 2 is on the essential? We can conclude that if you're down to the emergency bus, you won't have any power for either igniter, so an air start is not possible. Needing to do an air start when on emergency power would qualify as having a really bad day. But think about it a little further. The FJ33-5A engine requires the Gen 1, the starter generator, to be in starter mode to start the engine. Now, as far as I know, it's not possible to do a windmilling engine start. So if Gen 1 is totally up, then it's probably not going to work as a starter. So the lack of igniters is a moot point as you can't spin up the N2 section. But there's more to the igniter 1 and 2 circuit breakers. For igniter 1, the PIM says igniter 1 and ignition control panel. The PIM says ignition control panel also for the igniter 2 breaker. But the PIM totally fails to explain, at least to me, what the ignition control panel is or does. Now, by the way, don't forget that the FADEC alternates igniters with each engine start, but it uses both during an air start. This tidbit might come in handy during your next oral exam. Okay, my brain is boiled, so I guess that yours is too. We'll stop here and resume with the Copilot circuit breaker panel on the next episode of Circuit by Circuit on SF50 Real World Flying.